All right, guys, so this is your lesson for Friday, December 4th, or if you're the odd periods, then it's December 7th. So we're going to talk about function characteristics. We're going to go over a couple of different characteristics. You probably already know these, but just getting ourselves to be efficient and able to find the domain and range and different things like that. So we're going to go over these. All right, the first thing that we have. So you are able to take notes if you would like to. That is completely up to you. It would not be a bad idea, but again, that is up to you. Okay, so here are our first three characteristics we're going to talk about. So degree and then domain and range. Like I said, you guys probably already know domain and range, but it's always a good thing to go over. Okay, so for degree, so apologize for the handwriting. So the maximum or greatest or highest exponent in a function. So for example, if we have 3x to the fourth plus 2x to the third plus 9x minus 7, we would say that that function has a degree of 4 because 4 is the greatest exponent that we have in there, okay? Now, if we're looking at a graph, to be able to find the degree, what you do is you count the number of turns and then add 1. Okay, so I'm going to add that on here. So on a graph, we're going to count the number of turns and then you add 1. Okay, so let me show you what that means. All right, so if this is our graph, okay, so we're going to count the number of times this graph turns. So it's like reading a book from left to right. So we're going to start on the left. So our function is going down, and then here it turns. So there's 1 turn. And then it goes up, turns again here. There's 2. Goes down, that's 3. Comes up, there's 4. And then it keeps on going down. So we have 4 different turns in this function. Okay, so what that means is if I want to ask you what the degree of this graph is, you count the turns and then add 1. So we have 4 turns, and then we're going to add the 1. So this would be a degree of 5. Okay, again, we're counting the turns. You add 1, and that is the number of the highest degree. Okay, and I'm going to go over more examples here in a minute. Okay. All right, the next one, domain. So domain are your x values. So when we're talking about a graph, we're talking about how far left to how far right does the graph go, okay? And you guys are gonna be writing stuff in interval notation, okay? This is an example of interval notation. So what we mean by interval notation is that we're using parentheses and brackets, okay? So interval notation, when you use a parenthesis, that means you are not including the number that you're listing there. Okay, so for example, think about when we did, when you have a number line, right? And we had an open circle versus you had a closed circle. The open circle mean it was not included. The closed circle meant it is. Same thing here. So parentheses, and then when you have the brackets, that means that you are including it, okay? Now, because infinity is not an actual number, it's just an idea that it goes on forever and ever, so you can't include infinity. So that's why we use parentheses anytime we're using an infinity sign. So infinity always has the bracket, or I'm sorry, the parentheses, okay? And again, we're gonna be doing a bunch of examples, so you'll see how this works. All right, then we have range. I'm sorry, let's look at our example for domain. So if this is our graph, okay, we want to know how far left to how far right our graph goes. We're looking at the x-axis here, okay? So when I'm looking at this, I'm thinking to myself, all right, so if I were to take pieces of paper and to cap this off, notice there's arrows. That means this graph's going to just keep going and going and going in both directions. So what we say here, because our arrows are going in both directions, this is going to keep getting wider and wider. If I could make a piece of graph paper or a coordinate plane that was 100 by 100, it went from negative 100 to positive 100, this would still be going, right? So on this, we say that our domain is all real numbers. That's what we used to say. And in order to write that in interval notation, we write this as we're going from negative infinity to positive infinity. Okay? All right, range. Range are your y values. It's how far low to how far high your interval or that your graph goes. So for example, we have this graph here. So I want to know how far low to how far high our graph goes. Okay, again, if we think of the idea of taking two pieces of paper, this is as low as it goes. Because these have arrows, I can't cap that off. So this is as low as it goes. We're looking at the y-axis here, and that's at 0. And then it goes up forever and ever, so it goes to infinity. So we would write this as, we're including the number 0 because we actually have a point on 0, and it goes to positive infinity. Again, we're always going least to greatest. That's a big deal. All right, our next ones. So we have absolute max, absolute min, relative max, and relative min, okay? They're pretty much what they sound like, okay? When I say something is absolute, that means it's the absolute, like that is it, right? So when we're talking about absolute max, we're talking about the absolute highest point on the graph, even if the coordinate plane was extended. Even if I could have a coordinate plane that was as big as a classroom, no matter what, that would be the highest point. So let me show you an example. So on this graph here, right? So notice both of my arrows, both the ends are going down. So that means my graph will never ever go back up, okay? So we can see this right here, this point right here, this is the absolute highest place on that graph because the graph will never turn back up. The arrows are pointing down, so they'll never go back up. This is the absolute highest point, okay? The absolute highest point. So we call this the absolute max, okay? This is called a relative max because compared to the points around it, compared to over here and compared to over here, this point is higher, but this is not the highest point on the graph. Absolute max is the highest point on the graph, okay? And then this is the same thing here, the absolute min, except we're just talking about the lowest point on the graph, okay? So the absolute min here would be the absolute lowest place. Notice that both my arrows are going up, so these are gonna keep going and extending forever and ever and ever. So I'm not gonna have an absolute max on this graph. Okay, I am going to have an absolute min though, and it goes right there because that is the lowest point on the graph, no matter what. That is the lowest point. Now, this one is going to be our relative min because compared to the points around it, the area around it, it's the lowest point, but it's not the lowest point on the entire graph. Now, sometimes you're going to have graphs that don't have an absolute max or min, and that's okay. So we kind of talked about these already. So relative max and relative min. So compared to the points around it, this is the highest point, but not the absolute highest point. So it's just the max for that area on the graph. And the same thing with the relative min. So let me show you another example. So here, if you notice my arrows, if you notice every single time I'm looking at where the ends of my graph are going, right? So in this case, one's going down, one's going up. So I'm always looking at what direction these are going in. Because these are going in both directions, I can't have an absolute on this graph, right? Because it's going to go up forever and it's going to go down forever. So I can't have an absolute max or min. However, I do see that this area right here, this point right here, that is going to be called what's your relative min. Okay, relative min. Because compared to the points around it, that is the lowest point. But because this arrow goes down forever and ever, that means that this is not the lowest point on the graph. It just happens to be the lowest point in this area. Same thing here. This is called your relative max because compared to the points around it, it's the highest point, but you can already see over here the graph is already going up higher than that over there. Okay, so relative min and max means just compared to the area or in that spot on the graph that it is the highest or lowest point in that area, but not for the entire graph. Okay, another example, again, if you look here, again, I'm looking at my arrows, my ends, one's going up, one's going down, so I can't have any absolute on this. So this would be my relative min right here, and this would be my relative max. Okay? All right. Now, there are other times on graphs where you can have multiple maxes and mins. It's not just one. So if we go back to the first one we talked about with the degree. So if we look at this, this is a relative min, this is a relative min, so you have two of them on here. And then this is a relative max, and this is a relative max, so you have two of them. Now, with absolute, you can only have one. Okay, relative max and mins, you can have multiple of those, but for an absolute max or min, because that is the absolute highest point, you're only going to have one. The only time that that may be untrue is if you have a graph. I'm just going to draw it on here. So if you have a graph, right, and it goes kind of like this, and these 2 points are the same height, then you can say those are both absolute maxes. Okay, that's the only time you're going to have more than one, is when they are the exact same level, or they have the same y value. Okay, all right, so we're going to practice these. Okay, so I have some examples that we're going to go through. So first, we're just going to start with domain and range. Okay, we're just going to work through these and see how we do. All right, so we talked about this before. So domain on any parabola is always going to be all real numbers. And to show that in interval notation, it's just going to be negative infinity to infinity. And remember, we have our parentheses. Now, range is from bottom to top. Now notice that I have a bottom, but I don't have a top because my arrows go on forever. So my range here, my lowest point here is going to be 0. We're looking at the y, right? So looking at the y-axis, this is 0. And then it goes up forever and ever to infinity. Okay? It's okay to have a bracket and a parentheses. That's perfectly fine. All right, if we have a linear equation, so if we look at this, we're looking from left to right and then bottom to top. Well, from left to right, well, I notice my arrow is going to keep going forever in this direction, and it's going to keep getting wider that direction. So it's going to go on for infinity. So my domain is negative infinity to infinity. My range, this is going to go up forever. This is going to go down forever. So is negative infinity to infinity. Okay? For this example down here, for my domain, right? How far left and right? It's a parabola. We already know that's going to be negative infinity to infinity. My range, I have the highest point, but my lowest point goes on forever and ever and ever. So this is going down to negative infinity. So we have negative infinity going up to my highest point is going to be at 0. So it's going to look like that. All right, straight line across, straight horizontal line. So how far left to how far right? Well, it's going forever that direction, and it's going forever that direction. So my domain is going to be negative infinity to infinity. Now, my range is how high to how low. Well, this never changes its height, right? So for range, we're actually going to write it like this, y equals 4. Because it never leaves this area, it never leaves the y equals 4 for every single point on that line. So we're just going to write our range as y equals 4. Okay? All right, a couple more examples. All right, so if we're looking at domain and range, so notice my arrows are going down and up. Okay, that's important. All right, so that means this is going to keep getting wider and wider and wider. So domain is going to be negative infinity to infinity. My range, it goes up forever, it goes down forever. So my range is going to be negative infinity to positive infinity. All right, for the circle here. Okay, so I did not do a good job at drawing the circle, so we're going to have to estimate a little bit. So we go from we'll say negative 5.1 over to 4.3. So notice that that's as wide as it goes from left to right. So my domain is going to be, we are including it, negative 5.1, and this is going to go to 4.3. Okay. Now, I'm not going to give you a problem where you're going to have to estimate that. I'm just kind of showing you. I just didn't do a good job at drawing my circle. So range, -5.1. And it's going to go up to 4.3. Okay? So my graph does not get any higher than 4.3. My graph does not get any lower than -5.1. My graph does not go to the left any further than -5.1. And my graph does not go to the right any further than 4.3. Okay? All right, for this one, so domain, again, these are going in all different directions. We got one going down, one going up. We have a bunch of turns in here. So for domain, this is going to be -infinity to +infinity because this is going to go on. And as it goes on, it's going to keep getting wider and wider and wider. So if I were able to extend my x-axis forever and ever, this would just slowly keep getting wider and wider. So same thing here. So that's why it's going to continue to get wider and wider. So that's why we have positive infinity. For our range, so bottom to top, well, I got an arrow going down and an arrow going up. So that means that I'm going from -infinity to positive infinity. Okay, now let's take this one real quick and let's do a couple other things with this one. So if I look at this one, if I wanted to find the degree, then I would be looking at how many turns it takes. So it takes 1, 2, 3, 4 turns, right? And then we add 1, so that means we have degree of 5. If I can spell. Okay? All right, on this, we have some relative max and relative mins, okay? This right here is a relative max. This is a relative min. This is a relative max. You can have multiple of everything. This is a relative min, okay? Because we have arrows going in both directions forever, we have no absolute on this, okay? All right, next example. All right, so domain, again, this is just gonna keep going. We could make this wider and wider, and this would just keep getting wider and wider, and this would just keep getting wider and wider. So when we're talking left to right, our domain is gonna be -infinity to positive infinity. Range, bottom to top. Well, bottom, we have arrows going down, so we know that it's going down forever. But if you notice, we do have an actual highest point here. It goes up to this. So if I'm going across here, that's at 7. So my highest point here is at 7, and we put a bracket around that because we're including it because it touches 7. All right, if we looked at degree for this, we have 1, 2, 3 turns, and we add 1, so we have 4th degree. Okay, that means the function has the highest exponent for that function is going to be to that 4th power. All right, and then if we look at relative max and min, all right, so notice that both my arrows are going down, so I cannot have an absolute min here, but this is a relative min, because in that area it's its lowest point. This is a relative max. This is an absolute max, because the graph never gets higher than that point ever, no matter what. Even if I could extend this coordinate plane forever and ever, it would never get higher than that point, so that is your absolute max. Okay? All right, let's look at a few others. Let's jump on over to relative max and min. Okay, so if we're looking at this, this would be an absolute min. Okay, this would be a relative min because the arrow goes down here forever and ever. That means this is just a low area for that point, for that area. It's a low point for that area, but not for the whole graph. This would be a relative max because this arrow goes up forever and ever, so just in that area, that's a maximum. Okay, this graph has both down arrows, so this is going to be our absolute max. This is our relative max. This is our relative min, just like the other graph that we looked at. This right here, notice both my arrows are going down, so this point right here is going to be my absolute max. Okay, because it doesn't ever go higher than that. Okay, here, so on this one, this is going to be our absolute min, and this is also our absolute min. So they share because they're both at -2, y equals -2. So they're both the lowest point, so they're both absolute. This is a relative max because the graph goes up forever and ever. This one has no relative max or min, or absolute max or min. There's no turns, so we don't have any high or low points, so that just has none. Okay, here errors are going in both directions, so I can't have any absolute. So this is a relative min, this is a relative max, relative min, and relative max. Okay? All right, this one again, errors are going in both directions, so you can't have any absolute. So this is a relative max, and this is a relative min. Okay? All right, so you guys are going to have some work where you guys are going to do some of these on your own. If you need some help, please feel free to contact me. Thanks, guys.